So we shall continue from where we stopped. We previously had studied on system processes. Now I'd like us to look at network utilities. And network utilities are critical. They're the ones we use for simple tests on the network and to transfer files, for instance. So we have utilities such as the ping utility, the file transfer protocol. I think some of these you have tested before. You have learned them in networking. You have the Telnet, Finger, and they are part of the operating system that you have used before. As an introduction, it's good to remind ourselves that network utilities are software tools, and their purpose is to analyze and configure various aspects of computer networks. Utilities originated from the Unix systems. Most people do not know this because over time now we have migrated into Linux, we have it in Windows, almost every other operating system, in fact, including the disk operating system or the data operating system, however way you may want to refer to them, also have these utilities. Of course, this is because these Unix utilities have been ported to other operating systems. And the most common of these tools are found to be found in most operating systems are the ping, netstart, and port scanning. So the ping utility is a command that sends a network request to host available on the network, and using this command you can check if your remote host is responding well or not. So the ping command is very useful for that. I guess you have used it if you have done networking, come across it. The syntax we normally use for ping is you specify the host name after the ping, host name, and then the IP address. Also, or sometimes you could have the address, the name of the web resource. So ping works by, first of all, echoing what has been sent. We could probably start by the functionality. So that it's similar to how tapping a wall checks if someone on the other side checks if someone is on the other side. So ping sends out a special data packet. We call it the ICMP echo request towards the target device. Then, if the target device is reachable and operational, it sends a response packet back. We call it an ICMP echo reply back to your device. Ping measures the route trip time. We call it the RTT or time to reply TTR. I mean time to leave, and which is the time it takes for the request and reply packets to travel, and then displays this information on your terminal. The key information that is provided by ping is reachability and response time. Of course, you can also do an analysis and get to see about packet loss and verify network connectivity and measure network performance. So when you're using ping, for instance, I think this is something we could try. Maybe using the command prompt. You can use the command prompt for this because DOS also has it. So if I'm using ping, I would have something like ping command. Let's say is the localhost. You can ping the localhost just for testing purposes. 127.0.0.1. Enter, and of course you see it give me the reply. This is the time to leave, 1 millisecond, and then it reports the statistics. This kind of messages you get. Of course, this means that there is connection between my device. Of course, between my device and my device in this case. You could also ping an existing, let's say, website like yahoo.com. You can see that's impressive too. So we're able to get this the route trip times in milliseconds. So you can try this. Of course, to clear the screen in DOS, you type CLS. So say CLS. That's it. You can try this yourself on your end. Don't know whether you get it. www.jquat.ac.ke. This one seems to be taking time. I think probably we've not I've not written it well. Maybe anyway, you could test it at your own free time and see how it works. But of course, we have seen that maybe it's my local network that is not stable. I think it's okay. So you can test this on your end and you see how it works. So that's ping and how it works. Then we have the file transfer protocol. The file transfer protocol is an application layer protocol that moves files between the local and the remote file system. The idea behind the FTP, as it sounds, uh, is that you have a file that needs to be transferred from the local file from the local device to the remote device. This kind of transfer is okay, especially if the devices are on the same operating on the same platform. But most of the time, these devices are not on the same platform. You could be sending a file from your local machine to a server. The server could be in Linux or could be in a different platform and using Windows, for instance. It could be using a different startup file format and so on. So the issues that the file transfer protocol or the standard comes to address, it runs on top of the transmission control protocol. It's like a hypertext transfer protocol. It transfers the file. It has to establish two connections, two TCP connections, which are used. Used by FTP in parallel. That is control connection and data connection. So the FTP as a standard communication protocol has various other protocols like HTTP, which are used to transfer files between computers, but they lack clarity and focus as compared to the FTP. FTP is clear. You know, the thing here is that we can use FTP for transfer of files, and with it we can be able to transfer files in ASCII standard, EBDCIC, or image files. Image files are transferred as binary files. The ASCII standard, or this American Standard Code for Information Interchange, is the default file share format. We have also the EBCDC, EBCDIC, I think extended binary code data interchanges, something like that. So and of course ASCII comes with the MBT. So the image file format is the default format for transforming binary files. We have several types of FTP. We have anonymous FTP, password protected FTP, FTP secure, FTP over explicit SSL, and secure FTP. Now, the secure FTP is actually not an FTP protocol. The others are. Based on the level of security, that's how they're named. You can get the details. You can read by yourself and get the details. So the FTP then becomes a client-server protocol that has two communication channels: the command channel for conversation control and the data channel for file content. So a user has to log into an FTP server first, and there may be some servers where you can access the content without logging in, known as the anonymous FTP. Then the client can start a conversation with the server upon requesting to download a file, and the user can start different functions like upload, delete, rename, copy file, etc. on the server. You have two major types of connection: the control connection and the data connection. The control connection is for sending control information. The data connection is for sending actual files. So you can see, of course, represented in the diagram. So what happens is that when an FTP session is started between a client and a server, the client initiates a control transmission control protocol connection with the server side. The client side control information will control information over this. So when the server receives this, it initiates a data connection to the client. The control connection remains active throughout the user session as the files are being transferred. So FTP will need to maintain a state throughout the session, as compared to other protocols that are related, such as HTTP, which are stateless. We have the FTP clients, which work on the client server model, as you have mentioned earlier on, and you can use commands to establish a connection. Some of them, like get the file name, as you can see here, get the file name and retrieve the file name from the server, get the file name, retrieve the multiple files from the server. A S list of files, you use IS, you list the files available in the current directory of the server. So there are also built-in FTP programs which make it easier to transfer files and does not require remembering the multiplicity of commands. We have data types such as the ASCII, which is basically the American Standard Code of Information Interchange, EBDCI, these on IBM's character set, which is identical to ASCII. Of course, eventually ASCII has taken the market standard. Image, basically binary, and local files. FTP replies will be 200, command OK, 530 not logged in, 331 username OK, and service closing connection, 502, command not completed, and the others are listed there. So the characteristic of FTP include the fact that it uses a TCP as a transport layer protocol. Is good for simple file transfers, such as during boot time, errors in the transmission or lost packets, checksum errors, must be handled by the TFTP server. So FTP also uses only one connection throughout well-known port 69, and TFTP uses a simple lockstep protocol. So each data packet needs to be acknowledged. Simple lockstep protocol. The other utility we have is the Telnet, which stands for Teletype Network. This one is also a client-server application protocol that provides access to the virtual terminal of remote systems on local area networks or the internet. So what happens is that the local computer may use a Telnet client program, and the remote computer uses a Telnet server program. So there is a server, there is a on the server side there is a server program, on the client side there is a client program. So these two communicate in a client server mode, so that now the exchange happens. Telnet becomes a type of protocol that enables one computer to connect to the local computer, and is used as a standard TCP/IP protocol for virtual terminal service, and is provided by ISO. So the computer which starts the connection is known as the local computer, and the computer which is being connected to becomes a remote computer. So during a telnet operation, whatever is being performed on the remote computer will be displayed by the local computer, and telnet operates on a client-server principle, as is evidenced by just what you mentioned. How does it work? There is a client-server interaction where the telnet client initiates the connection by sending requests to the telnet server, and once the connection is established, the client can set commands to the server, and the server processes these commands and responds accordingly. You see, that description explains clearly what we mean by client server in this case. Then there is a character flow. When the user types on the local computer, operating system accepts the characters. The Telnet client transforms these characters into a universal character set called the network virtual terminal characters. And these NVT characters travel through the internet to remote computer via the local TCP/IP protocol stack, and the remote Telnet servers convert these characters into a format understandable by the remote computer. So the remote operating system receives the characters from a pseudo terminal driver and passes them to the appropriate application program. This is the character flow. Then you have the network virtual terminal, which basically Internet provides a common structure shared by different types of real terminals. It ensures communication compatibility between the various terminals. These terminals could have, for instance, different operating systems. There is a set of terminal commands, and these commands are organized in the format IAC, command code, and option code. So you can see some of them here. So we have, for instance, some codes, the option and the meaning. 0 is for binary, 1 is for echo, 3 is for suppress, go ahead, 5 is for status, and so on. We have 32 for terminal speed, 34 for line code. We use Telnet for remote administration and management, network diagnostic, understanding command line interface, access bulletin board systems, and automatic automation of and scripting. The modes of operation, we have default mode, the character mode, and line mode. So default mode is, if no other modes are invoked, then this mode is used. Echoing is performed in this mode by the client, and also the user types a character and a client echoes the character on the screen, but it does not send it until the whole line is completed. So in the character mode, each character typed in this mode is sent by the client to the server, because anyway, it's a client-server model. A server in this type of mode normally echoes characters back to the to be displayed on the client screen. Then you have the line mode, where line editing, like echoing characters, erasing, etc., is done from the client side, and the client will set the whole line to the server. The last among the utilities is a finger, which is a network utility used to retrieve information about users on a local system, or in some cases, remote system. It acts as a digital directory service, providing details about other users who are logged in. The output of finger consists of things like the username, full name, the login shell, idle time, terminal, and messages. The potential uses of this finger in network management is to identify the logged in users and check user availability. There are security considerations that are related to finger, and therefore it has limited use on modern systems, and alternative methods are being used. So basically, these are the four utilities that we needed to learn about, or to have a hint of, just in case, so that you can understand that they are mothered from the Unix operating system. And because we are studying system programming at a certain level, then when two remote machines need to communicate, these are the utilities that are exploited. It is part of what forms the network operating system, really, within the operating system. The ping utility, the file transfer protocol, we have the finger, and we have the telnet. So I'll expect you to go through this by yourself and hopefully be able to respond to related questions.